Howdy. Good afternoon and welcome to your science review with Mr. Blades. I'm going to work a few problems and see if anybody likes to ask any questions, and then we'll see after that. Let's get started. So I'm working off of the review that is posted in my website, in my Google Drive, so you can follow along until somebody says something different. I'm just going to do these. So, just still figuring out where the camera can see. All right, so we have force on our y and time on our x. What does this graph tell us? This graph tells us that we have a lot of force and then less and less down to zero force over a period of time. Now, what can we find out additionally from this graph? Well, we know that we can calculate our impulse by calculating the area under a force by time curve. So if we just figure out, if we know what this force is and what that time is, using our area equation for a triangle, 1/2 base times height, that would tell us our impulse over that period. Let's see, can I get better focus on this? Yeah, I don't know why it suddenly got better. Oh well, there we are. I see we have a couple people starting to sign in. Please text me questions so I can answer a little more specifically. Okay, but in addition, let's ask what we know from this graph. Well, we know that it had a lot of force and then down to no force. So since we know that force causes an impulse, we have a lot of impulse right here or a lot of acceleration, then no acceleration on a constant velocity after that point. So let's move on. Okay. Number 2, a hockey player hits a stationary hockey puck, which has a mass of 0.2 kilograms. The hockey player gave the puck an impulse of 6 Newton seconds. At what speed will the hockey puck move across the ice? Okay, so you may notice right there where it says 6 Newton meters per second. That is actually a typo. It should be Newton seconds or kilogram meters per second. So let's just black that out right there. And let's go ahead and get started. So our stationary hockey puck has a mass of, that's an M, mass of 0.2 kilograms. And since it said it was stationary, it has an initial velocity, let's go ahead and say V0, of 0 meters per second. It has an impulse, so J or delta P, don't forget both of those mean impulse, equals 6 Newton seconds. And what speed will the hockey puck move across the ice? Okay, so we know that our change in momentum is equal to our force multiplied by our time. We also know that it is equal to mass times our change in velocity, Vf minus Vi. And we can also calculate it as P final minus P initial. So let's go ahead and see which of these we can use. So we know we have an impulse, so that's why we narrowed it down to these equations. We know an initial velocity, and we're asked to find a final velocity. So that gives us this equation right here as the only one that can tell us what we want to know. So delta P equals mass Vf minus Vi. We know our delta P is 6 Newton seconds, and we know our mass, and we know our initial velocity, which leaves us with only one unknown, so we can solve this equation. Okay, so we have 6 equals 0.2 VF. Divide both sides by 0.2. And our VF is equal to 6 divided by 1/5, or 6 times 5, 30 meters per second. I should have gotten out my calculator earlier on. Oh well, we'll figure it out. Okay, so right there we go. That's the answer to number 2. Now, you guys might be a little bit confused by the existence of 2 units for essentially the same thing, but I assure you, and I will show you, hold on a second, calculator. I assure you that they are in fact the same thing. So let's go ahead and prove that real quick. Now, we have Newton seconds and kilogram meters per second for our units for momentum. And again, I submit that they are in fact the same thing. Kilogram meters per second is easy to see because we have momentum is equal to mass times velocity, or kilograms multiplied by meters per second. And that gives us our kilogram meters per second. Now, a Newton second is equivalent to this because if we remember, our force in newtons is equal to our mass multiplied by our acceleration, or kilograms meters per second squared. Okay, that's what a Newton is. We just call it a Newton even though it's a kilogram meter per second squared. Now, if we were to take newtons multiplied by seconds, or kilogram meters per second squared multiplied by seconds, that would cancel out one of those seconds and leave us with a Newton second of kilogram meters per second. So you can see they are in fact exactly the same thing. Where'd everybody go? I had 7, now I have 3. Oh well. Number 3. A force of 540 newtons is used to stop an object with a mass of 60 kilograms moving 180 meters per second. How long will it take the object to come to a complete stop? Now I'm going to do this 2 different ways, just in case one feels more comfortable to you. All right, so I'm going to do this what I would consider the right way first, and then we'll move on. So a force, a force of 540 newtons and a mass of 60 kilograms and an initial velocity of 180 meters per second. And since it says that we're trying to stop the thing, we know that our final velocity is 0. Now, because we're actually slowing down, if we assume that this initial velocity is positive, that actually means this force must be negative. Remember, we said that if we have a velocity and a force with opposite signs, then we're slowing down. All right, so the initial way. Since we're talking about a change in velocity, we can reasonably assume that this impulse equation is going to be at play. But since we have a force in it, there's also a spot for this guy right here. Okay. Now, we know that our impulse is going to be the same, so we can set this one equal to this one and rewrite our equation as force delta T equals mass VF minus VI. All right. So let's see if we know enough about this equation to actually solve it. We know our force. We don't know our time yet, but we do know our mass, our final velocity, and our initial velocity, leaving only one unknown. So we do know enough, and we can solve it. So let's go ahead and divide both sides by force, and so we can get delta T all by itself on one side, since that's what we're looking for. So delta T equals mass delta V over force. Okay, so our time is equal to 60 kilograms multiplied by 0 minus 180 divided by 540. Let's see what that is. So 60 multiplied by negative 180 gives us 10,800. Negative 10,800. I'm just writing it down so I don't forget right here. Divided by 540. Or we have a time of 20 seconds. Okay, these negatives cancel out. We have 20 seconds. Okay, good. But I said I was going to do this two ways, so let's go ahead and see what else we can do. We have a force, we have a mass, and we should remember from the last unit, F equals ma. 540 newtons equals 60 kilograms multiplied by whatever our acceleration is. If we divide both sides by 60, 540 divided by 60, wrong way. 540 divided by 60 equals 9. We have an acceleration of negative 9 meters per second squared. And we should remember that acceleration is delta v over delta t. So we could calculate our delta t by delta v over acceleration. So we can figure out our delta t by taking our delta v, or 0 minus 180, divided by negative 9. And you can probably tell that negative 180 divided by 9 is also 20 seconds. Again, like I mentioned in class, one of my favorite things about this subject is that almost everything can be calculated in more than one way. Number 4, a Nerf gun shoots a dart. Which is greater, the force of the dart, or the dart on the gun, or the gun on the dart? Force, equal and opposite reactions, guys. Equal and opposite reactions. So which has a greater force, the dart or the gun? Equal. Equal. Which has the greater impulse, the dart or the gun? Now this one might seem a little less obvious, but while we have a gun and a dart pushing against each other, it should make sense that they are in contact for the exact same amount of time. The gun can't be touching the dart unless the dart is touching the gun, right? So their delta t should be the same. And we already said that our force for that collision is the same as well. And we've shown multiple times that our impulse is equal to force multiplied by time. And if the time is the same and the force is the same, then their impulse is the same. But, Mr. Blades, how could that possibly be true? Which has a greater change in velocity? Which one has more mass? Obviously the gun. Which one has a greater change in velocity? Don't forget that our delta p is equal to our mass multiplied by our change in velocity, right? And even though their impulse is the same, the dart has a much lower mass. And in order for this to stay the same, if the mass is low, the delta v must be high, which is why the dart has a much higher change in velocity. And we already said that their change in momentum is the same. So there we go. Number 4, all the way done, start to finish. Number 5, a car with mass 500 kilograms travels at a velocity of 30 meters per second. What is its momentum? Another car with a mass of 1,500 kilograms has the same momentum. How fast is it going? Okay, so let's go ahead and say M1 is equal to 500 kilograms. M2 is 1,500 kilograms, and V1 is, what is that handwriting? 30 meters per second, and we're solving for V2 and P1. Okay, so our momentum is simple enough. Momentum is equal to mass times velocity. We know our mass, we know our velocity. So 500 kilograms multiplied by 30 meters per second, that gives us 15,000, right? 15,000 kilogram meters per second. 15, 10, yep. Boom, there we go. And now the question said that if the other car with a greater mass has the same momentum, how fast is it going? Again, we'll just use this same equation, P equals mv, but this time we know P and m, but not v. So 15,000 equals 1,500 kilograms multiplied by whatever the velocity is. Divide both sides by 15. Check and make sure. Yep. All right. Okay. Yep. Divide both sides by 1,500. This, that, and two of those zeros. V is 10 meters per second. Okay. Now, does this make sense? Now, it should, because the mass for object 2 is 3 times as big than object 1. And just like we've said before, if the mass is low, then the velocity has to be high. So likewise, if the mass is high, then the velocity has to be low. So when the mass goes up 3 times, the velocity goes down to 1/3. Okay, let's do a quick recoil collision. Okay, boom. All right. So I'm going to make this up as I go along. So if it doesn't work out, tough. Boy on a skateboard. Mass of the boy, 1, let's say 60 kilograms. Mass 2 of the skateboard, let's say 3 kilograms. Okay. And their initial velocity is, let's say, 5 meters per second. Okay. Oh, well. Anyway, if the boy jumps backwards off the skateboard at, let's say, 7 meters, okay, I can already tell it's going to be bad. If the boy jumps off the skateboard backwards at -2 meters per second, backwards in the opposite direction, how fast does the skateboard travel away? We don't know yet. Okay, we know this is a recoil collision because one object is becoming 2 objects and flying apart. So let's get started. We know our equation is m1 v1 plus m2 v2 equals m1 v1 prime plus m2 v2 prime. We know that already. But since the boy is riding on the skateboard, we can say that these two are equal. Okay, so we have m1 60 plus 3, so 60 plus 3, the two masses m1 and m2, multiplied by our initial velocity, 5, is equal to our mass, 60 multiplied by -2, his second velocity, plus 3 kilograms multiplied by whatever our v2 prime is. We don't know our v2 prime. That leaves us with exactly one unknown. So 63 times 5 is 315 equals 60 multiplied by -2 is -120 plus 3 times whatever v2 prime is. Add 120 to both sides. Ran off the bottom there. 435 equals 3 v2 prime. Okay. Add both sides by 3. Then our V2 prime is equal to 435. So right. Okay. 435 divided by 3, or 145 meters per second. Okay. So it feels like that makes no sense at all because that's a big number. However, it does in fact make sense. I mean, our math is correct. 60 plus 3 times 5 is 315. 60 times negative 2 is negative 120, and 3 is our mass there. Our arithmetic is right, but let's try to make sense of this answer over here that feels like it makes no sense at all. 5 meters per second is pretty fast. That's like 16, 17 feet per second. That's pretty quick. And for the boy to be moving forward at 5, he has 300 kilogram meters per second of forward momentum. He suddenly jumps backwards off the thing at negative 2 meters per second, giving him negative 120 kilogram meters per second of momentum. That is a change of 435 420 kilogram meters per second of momentum. That is a big change, and as a result, the much less massive skateboard flies off in a very fast 145 meters per second. Yeah, I made this up right here on the spot, which is why my answer makes no sense at all. But it's still correct. Number 6, a diver with a mass of 80 kilograms jumps from a dock onto a 130 kilogram boat at rest. If the velocity of the diver in the air is 4.1 meters per second, what is the final velocity of the diver landing in the boat? Okay, so for the person jumping off onto a boat and then person on boat drifting down. Okay, so we start off with 2 objects, a person in a boat, and we end up with 1 object, a person on a boat. So that makes this an inelastic collision. Okay, we still use m1v1 plus m2v2 equals m1v1 prime plus m2v2 prime. However, since the person is on the boat, v1 prime and v2 prime will be the same. So let's get started. Mass 1 is 80 kilograms. Mass 2, the boat, is 130 kilograms. V1, the velocity with which the man is moving to begin with, is 4.1 meters per second. And the initial velocity of the boat, says at rest, is 0. So we know M1, we know V1, M2 and V2. We know M1, we know M2, but we don't know V1 and V2. But we already said these two are equal. So these are the same value, which leaves us with only one unknown. So 80 multiplied by 4.1 plus 0 equals, we can add these two together, 80 plus 130 multiplied by v prime, which we don't know yet. So 80 times 4.1 equals 328. That's how much momentum is present in the system, and that's how much momentum must be present over here. So 80 plus 130, or 210 kilograms, multiplied by v prime meters per second. So divide both sides by 210. And we have a v prime of 1.56 meters per second. There we go. That's all there is to this guy. pretty straightforward. Same kinds of things. Okay. Actually, I'm going to call an audible, let you do number 7 down here on your own, because I've already done a recoil collision, so I'm going to do a elastic collision. So let's go ahead and get started. So if I have 2 balls, one hitting the other, and then afterwards both of them headed off in the same direction. Let's go ahead and say M1 is 0.5, M2 is 0.3, V1 is 1 meter per second, and V2 is initially 0. Let's say V2 prime is 0.7 meters per second afterwards. We know our equation is M1 V1 plus M2 V2 equals M1 V1 prime plus M2 V2 prime. Now let's go ahead and plug in everything we know and see if we know enough to solve. So we have 0.5 multiplied by 1 plus 0.3 multiplied by 0 equals 0.5 V1 prime plus 0.3 times 0.7. Okay, so 0.5 times 1 is just 0.5. That's 0 equals 0.5 V1 prime plus 0.21. Subtract 0.21 from both sides, and we have 0.29 equals 0.5 V1 prime. If we divide both sides by 0.5 or multiply by 2, same thing, we end up with a V1 prime of 0.58 meters per second. Sorry for the internet troubles, but I hope this was helpful, and I'll see you in class.